Imagine it's 2 in the morning. A lone developer sits in front of a split-screen terminal. On the left, the architecture for Google's Gemma model. On the right, the reasoning pathways from Anthropic's Claude. They drag the raw weights from one model directly into the other's configuration file. The result is Darwin 31B Opus, a hybrid artificial intelligence built by the community that blends open-source speed with enterprise-grade logic. Nobody signed a partnership agreement to allow this. No executives shook hands. A group of independent developers on Hugging Face simply saw two distinct tools and decided to stitch them together. The constraints of technology have flipped. Innovation is no longer confined to corporate walled gardens. It is happening out in the open, driven by builders who treat code as a raw material they can mold at will. Compare that speed to the physical world right now. In Islamabad, diplomats are sitting in quiet, heavily guarded rooms, slowly negotiating terms between the US and Iran over access to the Persian Gulf. This graph tracks the economic friction happening at the exact same time. Look at this line climbing upward. That is China raising its trade barriers on American products, hitting an exact 125% tariff rate. Downstream, that friction hits global logistics. Massive shipping operations are stalling out, with colossal tankers forced to reroute thousands of miles to avoid the Strait of Hormuz entirely. Our physical supply chains operate in a state of scarcity. For one nation to secure a border or protect a trade route, another entity inevitably has to wait. But everyday people managing businesses cannot pause their lives for a geopolitical stalemate. When physical borders freeze, they engineer a digital bypass. In closed institutions, hiding information is a defense strategy. In open digital networks, daylight is the best armor. When a security compromise hit the Axios tool, OpenAI didn't bury it. They published protective patches within 48 hours. Because this node graph is open, developers worldwide instantly grabbed the patch, running automated scripts to secure their codebases before the day ended. Think about the contrast. A diplomatic crisis takes weeks just to organize a meeting, while a global software vulnerability is diagnosed, shared, and neutralized over a weekend. In a hyper-connected world, radical transparency acts as an active immune system for progress. When one person spots a threat, the entire network learns how to defend against it. And this network is finding ways to bypass physical scarcity too. Right now, the biggest bottleneck in artificial intelligence is the massive amount of expensive computing hardware required to train new models. Researchers at MIT just attacked this limitation directly by developing a technique called compressSSM. We can see the efficiency on this performance chart. By using control theory mathematics, the compressSM curve reaches the exact same level of accuracy as standard models, but it uses up to 50% less computing power, plotted here as flops, to hit that target. While nations argue over access to finite microchips and energy grids, engineers are halving the cost of computation using strictly logic. Now watch what happens when you connect all these threads. A developer downloads that independently merged Darwin model and pairs it with the latest transparent security patches. A small startup team can run that setup locally on their own machines, completely bypassing the massive cloud servers that are currently tangled up in physical supply chain delays. They plug their AI into Pensieve, an application that maps out internal company data, projects, timelines, past decisions, so the model actually understands the specific context of their business. This setup allows the model to ingest the specific shipping manifests and the new 125%